Hello, yes, welcome to JSM. In this session, I am going to explain that coordination number of a atom in a crystals. Okay, so coordination number, nothing but here I am defining that coordination number is nothing but the maximum number of nearest neighbors to a atom. Usually, we can call that coordination number. Okay, so coordination number, nothing but the maximum number of nearest neighbors to an atom, usually we call that coordination number. Okay, see, this coordination number is possible to explain for the two different type of crystals. So generally we have that monoatomic crystals, nothing but a crystal which is containing only one type of atoms, or we have that ionic crystals. Okay, so in this session especially I am going to explain about that monoatomic crystals coordination number. Okay, so in cubic system we have three different type of one. So first I am going to explain the coordination number of an atom in primitive cubic or simple cubic. Okay, here I am taking that only monoatomic crystals. I am not explaining that coordination number for that ionic crystals. Of course, for that ionic crystal actually is a diatomic molecule. So two types of anion is there. If you want to define that coordination number of the cation, so here we are giving that the maximum number of surrounded anions to that cation, usually we can call that coordination number of the cation. So vice versa also we can possible to give that coordination number of anion. Okay, so here remember I am explaining about that only monoatomic crystal. Okay, so now let us take the simple cubic. So in simple cubic, you know that the lattice points are present at corners. Okay, so for example, if you are choosing it is in a cubic system. Okay, so in this cubic system, where the lattice points are located? The lattice points are located at only corner. So cube usually containing how many corners? 8 corners. Okay, so here the lattice points are present at corner. So choose any atom. Okay, so that must be surrounded with 6 atoms in this one with the shortest distance A. Okay, so generally the coordination number for a simple cubic is 6. Okay, with shortest distance A, with the shortest distance A. So generally in cubic system you know that what are the edge length you are taken as A, and this one is also A, and this one is also A. So for example, if I am choosing this, okay, I am observing this atom. Okay, so it is surrounded by with the shortest distance A, here the 1, and here the 2, and here the 3. Okay, so within this unit cell, so this is surrounded with the shortest distance A, how many? 1, 2, 3. Okay, so this unit cell, actually the corner is responsible for that 8 unit cell. That means with the same distance here we can expect one more atom or not. Okay, so that means I am taking as an F4 with the same distance. Okay, here also I am expecting that one more atom which is surrounded with that shortest distance, that is the 5, and with this same we can expect here 1. So totally how many atoms are there? This particular corner atom surrounded by that another 6 atoms with the shortest distance A. So that's why the maximum number of nearest neighbors to this atom is how much? 6. So that's why I am saying that coordination number for simple cubic is 6. Okay, so with the shortest distance is how much? Shortest distance is equals to A, we are taking that one. Okay, see, sir, why you are not calling this one? See, it is not a shortest distance. Why? Because see, generally in the face center, this is the root 2A distance, you have that one. So we can possible to say that this is the second nearest neighbor. Okay, It is not a first nearest neighbor. It is a second nearest neighbor atom. But the first neighbor with the distance is how much? A. So that's why I call that the maximum number of nearest neighbor atom only I am choosing as a coordination number. Got it? Now let us see in the coordination number of an atom in face-centered cubic. So generally the coordination number of the face-centered cubic is 12. Okay. So face-centered cubic nothing but the atoms are present. The lattice points are located at corners, 8 corners, and also 6 face centers. Okay. So here I shown that the lattice points where it is located in the face-centered cubic. So generally here one of the line I drawn, okay, hypothetical line which I drawn between the two opposite corners of the same face, which I called as in a face diagonal, whose that length is that root 2a. Okay. So now I am observing this face centered. This face centered. So this face centered generally is surrounded by how many lattice points here? So here I observed with respect to of this. Okay. So shortest distance, how much you can expect from root 2a by 2. Okay, here to here the root 2a, but from here to here how much? Root 2a by 2. And here also root 2a by 2. So from here to here root 2a by 2. Here also root 2a by 2. So the nearest neighbor, which is the shortest distance I am taking in this one, shortest distance is equals to root 2a by 2. Okay, so actually coordination number is equals to 12. So within the one unit cell it is somewhat difficult to show that one. So that's why I am utilizing the different type of unit cells here. Okay, I am showing the total 12 atoms how it is surrounded by this face center. Okay, so in the first one you got that idea. This face center is surrounded with 4 nearest neighbor atoms which are located at corners. Okay, so now look at this one. The next one, if I am taken with respect to another unit cell I am showing here. So the same one, okay, the same one. Generally, here also same, the lattice points are located at corners and face centers. Okay, so 6 face centers. So front face, the back face. Okay. Now observe in this one with the help of this same one. Okay. So here adjacent you have also one more unit cell. No? Okay. So here I am showing with respect to of in this. Okay, the second unit cell. So in this one also I have the lattice point at face center with the face center. Okay. Now observe this face center. It is also again surrounded by the top which is a present and at this bottom with root 2a by 2 and also here root 2a by 2, root 2a by 2. So total how many completed? Within the first one I shown with that 4 and in this one 4. So totally 8 completed. So another 4 I am going to show in another one. Just you can observe. Okay, so where the lattice points? Same, the lattice points are located at corners, okay, and face centers. Okay, now, so adjacent also we have one more now. See, adjacent one also containing the lattice point at this front face and back face. Okay, so that means here this lattice point which is located at the face center, is also surrounded, okay, with the same distance. You can observe in this one, root 2a by 2, root 2a by 2, okay. So now with the alpha of the face centered, when you observing this face center actually surrounded by 12 atoms with the shortest distance root 2a by 2. So that's why I am saying that coordination number in face centered cubic is how much? 12. Okay. Sir, okay, you are explaining with the help of the face centered. For example, if I want to observe with the help of the corner, okay, you can take any atom, okay, always you will be get that same coordination number either with respect to the corner or with respect to that face center. For example, if you are taking that a corner, okay, so the corner which is present in the cube, generally it is responsible for 3 face centers, okay. This corner is responsible for 3 face centers, nothing but it is surrounded by 3 face center atom. And you know that corner is responsible for 8 unit cells. So that means totally the corner is surrounded by how many? 24 face centers. Got it? So here the corner actually responsible for that. It is a common for 3 face centers. It is common for 3 face centers. But every corner is that, okay, responsible for that 8 unit cells. So that's why totally we can observe that it is surrounded by 24 face centers. But each face center is twice. Each face center is twice. So that's why 24 by 2, nothing but how many atoms you are going to get? 12 atoms you are going to get that one. Either with respect to face center or with respect to that corner. In face centered cubic, the coordination number is 12 with the shortest distance root 2a by 2. Okay. Now let us see in the body centered cubic. Okay. You know that already in the body centered cubic the lattice points are located at corner positions and also at the center of the body. Okay. So here usually that when you are explaining the coordination number with this center of the body, generally it is surrounded by 8 corner atoms. Okay. So that's why I am given that coordination number for a body centered cubic is 8. Okay. So what is the shortest distance here? Generally you know that when you draw that a hypothetical line between two opposite corners of opposite phases. Okay. So this one usually we know that root 3a. Okay. So this is, we can expect that root 3a. I can call that a body diagonal. Okay. So body diagonal when you are observing, so a hypothetical line which I have drawn between the two opposite corners of that opposite face. So root 3a is there. But from here to here, how much of the distance you are expecting? Root 3a by 2. Okay. So with the shortest distance, root 3a by 2. Okay. So the coordination number in body centered cubic, so generally how much? 8 with the distance of root 3a by 2. Okay. Sir, if I want to explain with the help of the corner. Okay. So with the help of the corner, when you observe that, generally this corner is surrounded by only one body centered cubic here. But every corner is responsible for 8 unit cells. So each unit cell contains one center of the body. So that's why this corner is surrounded by how many center of the bodies? 8 center of the bodies. So that's why we can also possible to give that the coordination number in body centered cubic either with respect of the corner or with respect of the center of the body. Each atom is surrounded by 8 atoms with the distance of root 3a by 2. So that's why the coordination number we are given as an 8. Okay. So totally we studied about the 3. One is the primitive cubic, face centered cubic and body centered cubic. Okay. So this is already I am given explained about that monoatomic crystals. So what is the coordination number for primitive cubic? 6. Face centered cubic 12. Body centered cubic 8 with the shortest distance of a, and here root 2a by 2 and here with root 3a by 2. Got it? So this is the concept of coordination number. Thank you.